Okay, so we're supposed to compare f of x to g of x here, and I can see that they've got a lot of the same stuff. The amplitude is going to be the same because a is 1. The period is going to be the same because b is both 2. There's going to be no horizontal shifting because I'm not adding or subtracting anything to x. So no horizontal shifting from f to g or g to f. The only difference between these two, of course, is this plus 3. Now keep in mind that whether you add 3 to whatever this value is here, or if you add 3 to whatever the value is there, you're achieving the same thing. And then this is sometimes referred to as D, if you're talking about A, B, C, and D. But if you just compare these, imagine making like a table. Hopefully this is how you learned these transformations a long time ago. But let's say we plugged in 0 into f of x versus g of x. Okay, well, if I plug 0 into f of x, the sine of 0 is 0. So if I plug that into g of x, this is going to go to 0, and this is going to be 3 more. Okay, I could do something like, see, this can be multiplied by 2, so I want to do something that's easy. All right, how about pi over 4? So pi over 4 times 2 would be pi over 2. The sine of pi over 2 is 1. I know all this because of the unit circle. And so, but the point is, if I plug it in here, this part's still going to be 1, and then I'm going to add 3 to it. So when you start to compare these, it's always 3 bigger. It's always going to be 3 higher on the graph. So that's why this plus 3, whether it's plus 3 here, plus 3 here, let's see, this makes g of x be shifted up 3 from f of x. So it's going to just shift the whole graph up 3. And of course, you could do more points if you needed to, but it's similar transformation rules from algebra.